these different ways of actually solving forces and weight problems. Okay, and let's take a look at this first one, which is a force problem. And let me get the pen. So the force problems, basically the formula for a force is force equals mass times acceleration. Okay, so you have mass times acceleration. The unit for a force, and let me do this in a different color. Let me do it in blue. So a force is actually in a Newton. Mass is in kilograms. And your acceleration is a meter per second. And it's squared. Okay? So these are our 3 units for each of these. Okay, so let me go back with the pen color in red. So what we have right here, again, I'm going to start with circling content or numbers that I know. I've got 3,000 kilograms and 2 meters per second or meters per second squared. Okay, so the first one says, with what force will a car hit a tree if the car has a mass of 3,000 kilograms and it is accelerating at a rate of 2 meters per second squared? All right, so using this one, looking at this formula, I'm going to set up in the triangle where each of these are at. Remember, side by side you multiply. So mass goes here, acceleration goes here, and by default that leaves the force to be on top. Okay, so we know we have 3,000 kilograms, and that's your mass. So I'm going to put 3,000 right here, 3,000, and it's kilograms. Okay, 3,000 kilograms. It accelerates at 2 meters per second squared. So 2 meters per second and square it. All right, so side by side we're going to multiply. So using your calculators, we're going to multiply 3,000 times 2, and you get 6,000. So let me write that up here. 6,000 will be your answer. And a force is measured in newtons. So there's your answer, 6,000 newtons. Okay? Let's take a look at this one, which on your worksheet is problem number 6. They want to know what is the mass of a falling rock, and therefore the falling rock accelerates at a rate of 9.8 meters per second squared if it hits the ground with a force of 196 newtons. So again, using the formula, force equals mass times acceleration. Okay, so again, I'm going to put my M there, my A here, and force here. Okay, so I know that here I have 196 newtons. It says a force of that, so we're going to plug in 196 here. Okay, so 196 newtons. Okay, and they want to know the mass, so we're going to put an X here because I don't know what the mass is. But then it falls, and all rocks and everything that falls at a rate of 9.8. So yes, I put this in parentheses, but if it just read what is the mass of a falling rock if it hits the ground with a force of 196 newtons, if 9.8 is not given, that would be a known factor, that all objects fall at a rate of 9.8 meters per second squared. So using your calculators, now you see when I set this up, we're going to divide. One's on top of the other. So now we take our calculator, okay, and we're going to plug in 196 and we're going to divide it by 9.8. And when I do that, I get 20 as my numerical value, and mass is measured in kilograms, so it's kg. Okay? All right, now let's look at this one. Now this one's number 12 on your chart, on your paper there. It's near the little graph that's shown on there. And it says, if Jacob hits Esteban with in the face with a force of 50 newtons, and so let me circle that information so we know it's 50 newtons here. Let me go back and make sure my pen is on, sorry. With 50 newtons right there. How much force does Esteban's face give to Jacob's fist? So that means one give and take with back. If you're applying 50 newtons to an object, basically the object would push back on that same amount, which would be 50 newtons. So like I believe problem number 13 lists that something is moving at 12 newtons, the force given back would be it would be that same numerical value. So if you see this one, it says if something has a force of 50 newtons or a force, how much would it give back to it? It would just be the reciprocal, it would be the same on there. All right, now let's change topics here. Let's look at weight problems. Okay, now weight again is how much gravity pulls down on you. So when you look at weight, the formula for weight is F of G, meaning the force of gravity, which the unit for weight would also be in newtons, is equal to mass, which is in kilograms, okay, times, and not acceleration, but we're going to use gravity here. And what's the numerical value for gravity? Going back to the problem we had the other second ago, it would be 9.8 meters per second squared. Okay. Oops, sorry. Let me make that a 2 there. Meters per second squared. All right, so let's look at this problem. It says, what is the weight of an object that has a mass of 15 kilograms? So in setting up my triangle up here, so your force of gravity or weight would be up top, mass would be here, and gravity would be here. So we know we have 15 kilograms, so we're going to put that in the meter, or mass place. 15, kilograms. Let me make that a kilogram. Okay? And we're asked for the weight, and weight is up on top, so that's what we don't know. And by default, gravity, we're going to use 9.8. Okay? 9.8 meters per second, and we're going to square it. Okay. Now, pulling out your calculator, if it's side by side, what do? You multiply. Now, let's look at our calculator. Pull that out, 15 times 9.8, and you get 147, and the unit for weight is the same as a force. It is a newton. That's why we combine the newtons, the force, and the weight problems together. Now, here's a bonus one. What if you're given the problem, but now instead of kilograms, what if they give it to you in pounds? Well, I wrote a little conversion down here that 1 pound is equal to 2.2 kilograms. So in order to convert those pounds to kilograms, we're going to take that 110 pounds and we're going to divide it by 2.2 to get the kilograms. And so when I divide 110 divided by 2.2, I get 50. So therefore, 110 pounds is about 50 kilograms, okay? 50 kilograms. All right, so knowing this right here, they want to know its weight. So again, mass, gravity, and this would be the force of gravity up here. All right, so our mass now converted would be 50 kilograms. okay? We're asked to solve for the weight. So gravity would be, again, we're going to use 9.8 meters per second squared. And when I multiplied the two of those together, 50 times 9.8, you get 490. And the unit for weight would be in Newton. Okay, if you have any questions, please see your teachers. There is a worksheet for you to practice. When you're done, please go up and check to make sure that you got them correct. Thank you so much on these, okay?